Lesson 4.5 on solving polynomial equations. Kind of what we were getting ready to do, obviously, with lesson 4.4. So we're going to factor these, and then we can use that to solve. So the check is already kind of on the screen for us. Ignore that for a moment, right? But if you are asked to do these by hand, right, you are going to need to work to factor out this expression here. So I see out of the 2x to the third minus 12x squared plus 18x, well, they're all divisible by 2, and I can divide away an x from all three terms, right? So that's going to give me x squared minus 6x plus 9 equals 0, right? So I need to keep working to factor, see if I can't factor this x squared minus 6x plus 9. So I would check, okay, is there anything that multiplies to positive 9 but adds to negative 6? And negative 3 times negative 3 would give me the positive 9. And then negative 3 plus negative 3 would give me the negative 6. So my full factored form here is going to be 2x times the quantity x minus 3 times the quantity x minus 3. And then I can work to solve this just like we when we were solving quadratics, right? I'm going to set each of these equal to 0. Now, x minus 3 equals 0 is going to be a repeated solution, right? It appears, that factor appears twice, so I don't need to solve that twice, right? So I can divide away the 2 here. I get x equals 0, and I see that on my check graph right there. And add away this 3. I see also a solution at x equals 3, also right there on my check graph. So we had that repeated solution. That's where the graph, note that the graph of the related function touches the x-axis but does not cross at x equals 3. When it was x equals 0, it crosses. So when a factor x minus k is raised to an odd power, crosses the axis, and if we get something to an even power, it touches, right? So looking back at, we could have rewritten this right here as 2x, right? That's really to the first power, so that's a cross. And then this is x minus 3 squared. This even power tells us that solution is just going to touch the graph like we see right here. So for example 2, when we are asked to find the zeros, right, we want to know when does 0 equal, and then we're going to start working to factor all of this. So I'm going to try to factor out a negative 2. And that gives me x to the 4th minus, right, negative 16x squared divided by negative 2 would be negative 8x squared. And then negative 32 divided by negative 2 would be plus 16. Still working on factoring. I see that I can break this down into negative 2 times x squared minus 4 times x squared minus 4, right? What multiplies to 16 but adds to negative 8? It was the negative 4 and negative 4. Now I need to see, can I factor x squared minus 4? Is there something that adds to, or multiplies to -4 but adds to 0, right? There's a 0x hiding in this this polynomial there. And that would be -2 and +2. Right? So this is going to be 0 equals -2 times x minus 2 times x plus 2. That is just for this part right here. This part is going to be the same factors. X plus 2 times x minus 2, right? Because these two are the same. So that gives me 0 equals -2 times x plus 2 squared times x minus 2 squared, right? These are appearing even number of times. So these are going to be that situation where it touches the axis but does not cross. So I am going to work to solve x plus 2 equals 0, x minus 2 equals 0. So this would be x equals -2, x equals +2. Here and here is where I have solutions. If I graph that, right, these are going to come up and touch, and come down. For example 5, write a polynomial function f of least degree that has rational coefficients and a leading coefficient of 1 and zeros at 3, 2, and -4. So let's just kind of think about this a little bit. We're going to have solutions at -4, 2, and 3. Right? Those are where my solutions are. My solutions are the opposite of the constants in the factors. So this is going to be a -3, a -2, and a +4. Now, least degree means I keep all of my variable exponents as small as I can. Right? So this is going to be f of x equals this. So now I am just going to FOIL this thing out. F of x equals. I'm going to FOIL here. That's going to give me x squared minus 2x minus 3x plus 6 times x plus 4. Right? I just used FOIL for the x minus 3 times the x minus 2. I'm going to clean up the middle term here. And then I'm going to multiply that all by x plus 4. Right? So I'm going to multiply all three of these terms by the x. So x to the third minus 5x squared plus 6x. And now I'm going to come back through, multiply them all by the 4. Plus 4x squared minus 20x plus 24. Okay, running out of room. Gonna make it work. F of x equal to x to the third negative 5x squared plus 4x squared, so minus x squared. 6x minus 20x would be minus 14x. Plus 24. So if you are asked to write a function, a polynomial function with zeros, at certain points, right? X times the opposite of this 0, negative 3, x minus the 2, and x plus the 4. And we multiply those all out using FOIL or some similar strategy.